In this Hacker video explainer, let's take a look at the classic algorithm, binary search. So what is binary search? Well, it's a classic search algorithm and it's used for interviews all of the time. The aim is to find a value in a sorted list. But how does it work? Well, we repeatedly divide a list in half, which is why it's called binary search. We compare our target value with the middle element, and we repeat until we find our value or the list is empty. Let's now discuss the algorithm with an overview. The overview is, while the list is not empty, let's compare our target value with the middle element. If it's less than the middle element, split the list to the left. If it's greater than the middle element, split the list to the right. We then reset the middle element and start again. That's it. That's all there is to the algorithm. The idea here is divide and conquer. We reduce the search space and find the value with logarithmic time complexity. One of the best ways to make sense of binary search is with a simple visualization. So let's look at this now. We have a search value of 1 and a sorted list. As you can see, the elements in the array are sorted from 1, 2, 3, 4, 5, 6, 7. Remember, with binary search, the list is always sorted. Okay, so we do our first check. Is the value equal to the middle element? It's not. So we divide the list and reset the middle. Move on down to the next one. Is the value equal to the middle? Note the middle is 2, our search is 1. So again, we divide the list and reset the middle. Finally, we repeat and check if the value is equal to the middle element. And yes, it is. 1 is equal to the middle, so we are now completed. And that is how binary search works. Let's now put all of this into practice and code up binary search in PyCharm. So here we are in PyCharm. We've got some boilerplate in place. Let's create our binary search algorithm. We're using a sorted list, as you can see here. We've got the elements in sorted order from 1 to 7. The value we're looking for will be number 7. We need to fill out our algorithm here. So let's begin. We need to begin with putting the pointer for the first element equal to index 0. Then the pointer for the last element equal to basically the last element, which is to the length. The list we pass in, and -1, that makes a lot of sense. Next, we need to enter a while loop, and here we're going to check if the first is less than or equal to the last. What do we do next? We're going to set our midpoint. We're going to say our midpoint is equal to the sum of the first plus the last, then use integer division divided by 2. This means that we are getting the midpoint whether we have an even or an odd number of elements. We're always going to get the midpoint for the current list, no matter what the length is. Now, what do? We need to do our check, don't we? We want to check whether we've found the value or not. Let's say if the midpoint value is equal to the item we're searching for, we can return true because we have found our value. But if we have not found the value, we need to do something else. So we enter an else clause. So with this else clause, what we want to do, we want to check whether the item is less than or greater than the midpoint to know whether we can split left or right. So if the item is less than the midpoint, we're going to split left. And to do that, we simply need to change the pointer value for the last element. And we just say that is equal to midpoint -1, which makes sense because we're now moving 1 to the left of the original midpoint. On the other hand, if it's greater than, we're splitting right, another else, and we simply say, let's change the first rather than the last. We'll make this equal to the midpoint +1 because we're going 1 to the right of the original midpoint. The last thing is, if we haven't found our element after using this loop, we are going to return false. And that is now the end of our binary search algorithm. The final stage is to now test out our binary search algorithm. As you can see down here, we are searching for a value of 7 within this array. We will run using this line here, and this is going to print out true or false depending on whether the value is in the array. Let's run it and see what we get. And then we go true. That's what we would expect because 7 is in the array. Let's change it to 10, save, rerun. What do we get this time? False. Of course, 10 is not in our array. And there you go. You have now created your own binary search algorithm. Of course, there are many ways to do this, and you could even use recursion, which I think is a really elegant way to handle this binary search algorithm, considering we are reducing the search space. And recursion is ideal for reducing things. Anyway, that's all for this video. We hope you enjoyed this, and best of luck in your coding interviews when you encounter binary search. See you in the next one.